Number 6. The molar masses of helium and hydrogen chloride are 4.00 grams per mole and 36.46 grams per mole, respectively. What is the ratio of the mass of helium to the mass of hydrogen chloride, rounded to 1 decimal place? Right, so from helium to hydrogen chloride, that's 4 to 36.46. All right, so we're going to take this 36.46. We're going to divide it by the 4. We're going to get 9.115. Now the question is asking to 1 decimal place, right? And so we're just going to go 1 to 9. 1 to 9. Now, if you are sitting here thinking, why didn't you do 4 divided by 36.46? 4 divided by 36.46, what is that the incorrect answer? No, it is not an incorrect answer. It is a very appropriate answer. It's very correct. However, realize if you carried out that function, it would be a decimal. And you wouldn't have a ratio of whole numbers. Because remember, Gay-Lussac's law of combining volumes of gases says that they can be reduced to small whole number ratios. You wouldn't get a whole number here. You'd get a decimal. And that would make things a little bit more difficult for you in terms of the simple math that you're going to have to carry out. Now, can you still get the correct answer? Most certainly. If you did 4 divided by 36.46, 100% you could still get the correct answer. However, you'd be dealing with decimals, and if you guys are like me, you'd rather deal with whole numbers. So we divide the larger number by the smaller number so that we get our 1 to 9 ratio. B. Use your answer in part A to calculate the ratio of the average speed of helium to the average speed of hydrogen chloride. Remember, Graham's law states that the average speed, which is what we're trying to do here, the average speed of a molecule is inversely proportional to the square root of their molar masses. Right? Inversely proportional to the square root of their molar masses. So I have this ratio of 1 to 9. 1 to 9. And so if I square root both of them, I get 1 to 3. Right? There's a 1 to 3 speed difference here. But notice that I've switched them. Helium to hydrogen chloride is a 1 to 9 mass ratio, but it's a 3 to 1 speed ratio. Because remember, it's an inverse relationship. Whereas up on the molar mass ratio, the helium was the smaller number out in front, and the hydrogen chloride was the larger number in back. Because the helium had such small mass, it is going to move much faster, so I'm going to have a 3 to 1 average speed ratio. And C, if helium's average speed is 1,200 meters per second, what is the average speed of hydrogen chloride? And so we've given you the speed of the helium. We're asking for the speed of the hydrogen chloride. Remember that Graham's law is the velocity of A divided by the velocity of B is equal to the square root of molar mass of B divided by molar mass of A. We simply solve for velocity of B, because in this case, A is helium. We know what A is. We're going to solve for the velocity of B. Plug and chug, right? I'm going to plug 1,200 in for velocity of A, plug my molar mass of A in as 4, molar mass of B in for 36.46, calculate my square root first just to get it out of the way. I like to do that better. Multiply it by the 1,200 meters per second. I get 397.469 meters per second. But I'm only using one significant figure, so I'm going to round this up into 400 meters per second.